A ladder is placed against the vertical wall with its foot on horizontal ground. So this is the ladder. This here represents the ladder, and its foot is on the ground. This is the ladder with its foot on the ground. The distance between the foot of the ladder and the wall is 5.2 meters. So let's say this is the foot of the ladder here, and this is the wall. So the distance between the foot of the ladder and the wall is 5.2 meters. 5.2 meters. That's 5.2 meters. Okay, now the next one says if the angle of inclination of the ladder and the horizontal is 42 degrees, that's the angle of inclination of the ladder and the horizontal. This is the ladder here, this is the ladder here, and this is the horizontal here. This is the horizontal. So the angle of inclination is the angle of inclination between the ladder, let me use black, between the ladder and the horizontal is 42 degrees. 42 degrees. Now this now says calculate the vertical distance the ladder makes with the wall. So this is the vertical distance the ladder makes to the wall. I can just bring this out. I would have something like this. I'll bring this out. This. So you see, it looks like a right angle triangle. It's actually, from this we can actually bring out a right angle triangle. So this would be 5.2 meters. 5.2. This is the vertical distance the ladder makes with the ladder. Let's just take this as x, and this is the ladder. Let's say this is A, B, and C. So the distance AC represents the ladder, while the angle between the ladder and the horizontal distance is 42 degrees. Now from this, you notice we can use the tan ratio, because this here represents AC, is the side AC that faces the angle 90 degrees represents the hypotenuse, while the side that faces this side AB that faces the angle 42 degrees is called the opposite. This is the opposite, this is the hypotenuse, while this other side definitely is going to be the adjacent. So you see, we can use the tan ratio. So the tangent ratio, so we say tan 42 degrees is equal to the opposite, which is x, all over the adjacent, which is 5.2. So from this we can just cross multiply here. Well, there are 5.2 times tan 42 degrees equal to x times 1, which is x. So from this we can just take x to the left hand side, and we'll take 5.2 times tan 42 degrees to the right hand side. So this will just be x is equal to 5.2 times, now for tan 42 degrees we can use our calculator to find that. So we'll just say tan 42 degrees, this is 0.9 approximately, 0.9. so multiply this, so we have 5.2 times 0.9, and this is 4.68. So we'll write 4.68 as our result. Now you notice we're working in meters here, so we'll just put our final answer in meters. So this can be rounded up to the nearest whole number. I'll say x is equal to 5 meters approximately. So from this we can say that the vertical distance the ladder makes with the wall is 5 meters. Now let's solve this question. It says from point P, Jide cycles 18 kilometer north to the point Q. So let's say this is point P. Let's see this point. Let's just take this point as point P. So Jide cycles 18 kilometer north. You know, this is north, east, south, and west. So let's just follow that. So from point P, Jide cycles 18 kilometer north to the point Q. So just remember, this is north, east, south, and west. So Jide cycles 18 kilometers north. Let me do this like this. 18 kilometers north. So let's say this is 18 kilometers. 18 kilometers north to the point Q. So let's say this is point Q. Now from the point Q, this says then east to point R. So from point Q, Jide now moves east to point R. So let's say this is point R here. Let's just say this is point R. So this says if the bearing of R from P is 0.65 degrees. Now the bearing of R from P, so we'll start from P, we'll take the bearing of R from this point P, so we'll just move 0.65 degrees. Now let's say this is 0.65. You know the total angle from north to east is 90 degrees, so let's just take 0.65, which is still 65 degrees. So this says the bearing of R from P, so that's why we are starting from P and not R. From P is 65 degrees, that's 0.65 degrees. So we'll go to R from P, and this is it here. So this angle here is 65 degrees. So from here we can just bring out the right angle triangle. The triangle PQR is actually a right angle triangle. So we have, you know, this side is the hypotenuse, this is the hypotenuse. Now the side facing the angle is called the opposite side, and definitely this other side is the adjacent side. So from the question, we're asked to find the distance from Q to R. That's this distance here, which is the opposite. So we can use the tan ratio, because we have the adjacent side and we have, well, actually looking for the opposite side. So we're just saying tan 65 degrees equal to the opposite, which is QR, that's what we need, all over the adjacent, which is 18 kilometers. So we can cross multiply, and this will be 18 times tan 65 degrees equal to QR. So this can also be QR equal to 18. Just take what we have on the right hand side to the left hand side, and what you have on the left hand side to the right hand side, and for convenience sake, so you have this like this. Let's find what tan 65 is with our calculator. So say tan 65 degrees, this is 2.1445 approximately, 2.1445 approximately. You can actually use your tan table to find that, but since we have a calculator here, let's just use the calculator. So this is 18 times 2.1445. 18 times 2.1445, and this will give us 38.601. 38.601. What unit are we working in? We're working in kilometers. So kilometers. So we can round this up to the nearest whole number. This will be QR is equal to 38, no, not 38, 39, since this is 6, to be 39 kilometers approximately. So it means the distance from Q to R, correct to the nearest kilometers, is 39 kilometers.